Hello there, my name's Adam Spring and I'm going to run you through the laser scan data that we took with the 5010C from Ziller and Froelich, and this is clearly the Structure IO, which I'm sure Cameron has been talking about. Now the Structure IO is actually a repackaged Capri sensor, which is a smaller version of the sensor used inside of the Xbox Kinect, which is called the Carmine. Now, unlike the 5010C, this works on the principle of optical triangulation. So in this case, you have an infrared light which is projected out from the sensor, and you have two other sensors with a known distance between all three of them that gives you your sense of depth as you are basically scanning the surface. In this case, I guess kind of like a paintbrush in a way, is probably the best way to describe it. Anyway, once the pattern is being projected onto that surface, you kind of have a window with this sensor of around about 1.5 to 3.5 meters of a sweet spot, because the depth of field is kind of sensitive on it. Also, if there's if you have sunlight, it's kind of an issue. This still from Paranormal Activity 4 kind of shows how it works best in the dark. Anyway, the sensor that we used, the Ziller and Froelich 5010C, was used for a particular reason. It has 1 million points a second generation, and it uses a rotating mirror to send out a laser beam. So the difference between the wavelength going out and the wavelength coming back is how you work out the measurement, essentially. And one of the things that this is used for, this is me in the image, is in the mining industry. So in terms of cave environments or cave-like environments, it was safe to use. It wasn't going to break. And another reason why we used it is inside of it, it had an HDR camera, which means that once you put the low light shooter on the top of it, we could get very, very nice RGB data, which you'll see in a bit, to overlay on our point clouds. Now, one of the versatile things about working in digital media is the fact that you can take the sight away, as you'll see as we fly into it here. This overview is actually showing you how the cave appears based on the outside scans that we were able to get, and also the inside scans as well. So we are literally able to give a complete indentation of the cave itself. Another thing we can do, because it is its own independent light source and because you can show things like surface normals, once you start processing it in softwares, you can actually play around with the surface reflectance in order to get a really good idea of, in this case, some carved faces on the surface. And obviously, primarily, the 5010C is used as a measurement tool, and it has its own known position in space. So its 000 coordinate is right at the center of the mirror where the beam actually hits when it passes out, and it rotates it over to create the 3D image that you're seeing here. In this case, with that RGB value from the camera with the low light shooter on it. The other thing is, in small to reach surfaces, you know, this was a test. This was basically showing Brent what we could do, and it really was, based on my experience, the best tool for the job. It was this one and one other scanner that could do it. So you can get into nooks and crannies, you can really go through, you can really have the experiential side of things, but also on the other side of it as well, you can also get a high accuracy, high precision and high resolution measurements that you wouldn't otherwise be able to do with normal solutions like a total station. In fact, the way I would describe this type of laser scanning is, and even to an extent with the Structure IO, is it's more concerned with surfaces than it is individual points. And as you can see as we fly out here, it's what do you do with the data once you've actually got it, because you're working at a scale that you've really not worked at before if you're working with total stations. So in conclusion, I will say, you know, it was 18 scans, it was full HDR photography, it was done over a 24-hour period as a sample. We can go back, put targets in, tie it into absolute coordinates. We also basically did it in, 349 million points is what you've seen, but there's 40 more than that. And in the end as well, we were also able to have fun. And, it's always good to have selfies in the middle of nowhere. Anyway, thanks for now. Cheers.